Okay, so here's our first example, and we're asked to solve. So we're trying to find the value of the variable. And so ideally when you're solving exponential equations, what you want to try to do is write the left side and the right side using the same base. And so if the bases are not the same, try to rewrite one of the bases as whatever the value is of the other base. So for example, I have a base of 4 on the left-hand side and a base of 64 on the right-hand side. And I'm going to think about whether or not I can change one of the bases so that they're exactly the same as the other one. And in this case, 64 would be the one I would change since it's the larger value. And I can probably write it with a base that's smaller. And I'm going to think about whether or not I can actually change 64 so that it's the same as the base on the left-hand side, which is 4. So let's play around with this a little bit. Let's see if I can write 64 with the base of 4 instead. So let's see if I can write it as 4 to exponent 2, which 4 to exponent 2 I know is 16. So let's try 4 to exponent 3, and that gives us exactly 64. So there is a possibility for us to actually just change this base so that it's the same as the base on the left-hand side. So that's what I'm going to do in this case. So I'm going to leave the left-hand side the exact same way that it was. But on the right-hand side, I'm going to change 64 so that it's 4 to the exponent 3, and then I'll apply the exponent of x on the outside. And now I know that when I have the power of a power using our exponential rules, I know that that'll just give me 4 to the exponent 3x. So now I have 4 to the exponent x minus 2 equals 4 to the exponent 3x. And since the bases are the same, now what that means, I can set the exponents equal to each other. And so that means I have x minus 2 is equal to 3x. So the only way this statement would be true is if the exponents were equal to each other. And so now I can rearrange the equation so that I can solve for x. I'll bring this x over to this side, and I'll get negative 2 equals 2x, which means negative 1 is equal to x. And you can check your work to make sure that this is correct by substituting it back into here. And if I plug in negative 1 here, I get 4 to the exponent, and I'll just do that very quickly. I'll use a different color so you can see it. So I would get 4 to the exponent, negative 1 minus 2, which is equal to 4 to the exponent negative 3. And on the right-hand side, I get 64 to the exponent negative 1, which is 1 over 64. And I know this will also give me 1 over 64. So because the left side and the right side give me the same answer, I know I've done that question correctly. Now the next one's a little bit different, so let's take a look at part B. I have 4 to the exponent 2x equals 8 to the exponent x minus 3. Now if I wanted to try to write the larger base as the same base as the smaller one that I have here, so if I try to write 8 with the base of 4, I know that's not possible. So what I might need to do in this case is actually change both of the bases to a base that might be common for 4 and for 8 as well. And so that base I know that I can use is a base of 2. Okay? I can rewrite 4 with the base of 2. I can also rewrite 8 with the base of 2. So that's what I'm going to do in this case. I actually have to change both of the bases to make it work. So if I change the left-hand side, I get 2 to the exponent 2. Instead of writing 4, I write 2 to the exponent 2. Then I get an exponent of 2x at the top. And on the right-hand side, I have 2 to the exponent 3, which is the same as writing 8, with an x minus 3 on the outside. And so what I could do in this case is simplify the exponent parts. So I have 2 times 2x, which is 2 to the exponent 4x. And that'll be equal to 2 to the exponent 3 times x minus 3. So remember that you're multiplying powers here. So I'm actually going to multiply the 3 with the x minus 3. And so that actually gives me 3x minus 9. And again, now because the bases are the same, I can set the exponent parts equal to each other. And I get 4x equals 3x minus 9. And so I can solve for x in this case. And if I bring the 3x to the left-hand side, or if I subtract 3x from both sides, I get x is equal to negative 9. Okay? So there's my solution for the second one. And again, if you want to just check your work quickly, this would be 4 to the exponent 2 times negative 9, which is equal to 4 to the exponent negative 18. And on the right-hand side, I would have 8 to the exponent negative 9 minus 3, which is equal to 8 to the exponent negative 12. And I can check these on my calculator. So 4 to the exponent negative 18 is a really messy number. And if I check the right hand side, 8 exponent, negative 12, I get the exact same messy number. So I know that my solution is correct. Okay, just a quick way to check your work.